Okay, let's look at this little thought experiment. So we have a person over here um, who is looking at a traffic jam, and the cars are moving pretty slowly. So they're moving at a speed of 4 meters per second, and they're all exactly the same car. They're all pretty bad drivers because they're bumper to bumper, and each car is 2 meters long. And the question we're going to ask you to think about is how many cars would pass that person in 1 second? Okay, and how we can think about this, I mean, we could do speed equals distance divided by time and use that, but just from what velocity means, 4 meters per second means those cars will move 4 meters each second. So in 1 second, these cars are going to move a total distance of 4 meters forwards, or 4 meters past this person. Now each car is 2 meters, so how many cars will that be in total? We just take the 4 meter distance that they're going to move, we divide it by the 2 meters that each car is, and it tells us, as you're probably able to just say, this person will see 2 cars in 1 second. Okay, or that's how many will pass them in 1 second. But this is also true of waves. So if each of those cars was a wave, like so, then we wouldn't be talking about a car length of 2 meters, we'd be talking about a wavelength of 2 meters. Okay, I mean, while that velocity would be the velocity that the wave's moving forward, of the progression of the wave. And this thing we calculated here, which was 2 cars in 1 second, that's the number of cars that passes the person in 1 second. In terms of waves, that'll be the number of waves that pass a point in a second, and that is our definition of frequency. And you see what we did to work it out. We worked out that the frequency was the distance they'll move forward in 1 second, which is just the velocity, divided by the length of one wave. Now, if we multiply that out, we then get the v, the velocity or speed of the wave, equals f lambda. Okay, that is known as our wave equation. It should be here in your notes. You can use a triangle if you want, but I don't advise it. You should be able to kind of manipulate those equations now. So speed equals frequency times wavelength, or v equals f lambda. You cannot invent your own letters for words. So for instance, you might say, well, I don't like drawing Greek letters, so I'm just going to call this W for wavelength. That's not what it's used for in physics. W means something else in physics, so you can't change that. So if you don't like writing lambda, write the full word wavelength, but don't replace it with something else that isn't the standard in physics. Now, frequency should be, speed should be measured in meters per second. Wavelength should be meters. It's important those two things match up. Okay, so if this was centimeters, this would have to be centimeters per second. We rarely use that, although it is used in one of the questions below here. And then frequency is the number of waves per second, but another way of saying per second, we just use this unit here, which is hertz, capital H, small letter Z. So we'll stop this video here. We will then do 2 examples in the next video, and then you should try the questions below.